projector. Okay, cool. That's not intricate. Okay, should we get started? I'll say that's yes. My name is Jake. I'm a grad student at UBC, in case you're wondering how else. This is going to be a really short Git workshop, kind of just the basics of how to set up stuff with GitHub and kind of start off your own project. We're not going to go into anything terribly advanced. It'll just be the kind of the main 5 commands that you'll spend your day doing. I will quickly make a pitch for why you want to do this. Doing stuff in Git will save your entire history of like all the edits that you ever make to a project. One of my university professors basically said, not using something like Git, you deserve all the terrible things that happen to you. If you lose backups of code, then it's your own fault for not using something like Git or SVN, or there's a lot of different things like this. So what we're going to do is just create a little example GitHub project. Oh crap. No, we're not. I'm going to run and grab my power cable, and then we'll get started. Maybe 2 seconds.
Yeah.
Yeah, I guess we're waiting for oh, John? Yeah. Okay. Hopefully you all have GitHub accounts, and if you don't, we should probably sort that out now. So all we're going to do is create a new repo, clone it, move some files around, and just kind of show you the idea of Git. Git is slightly different. I'll explain to other repositories, other source code repositories, where you have kind of an intermediate step. And I'll tell you why that is. But anyway, we're gonna, let's do this quickly. We're gonna make a new repository. You can follow along if you want, or you can just watch. I'll send around a Git cheat sheet that kind of lists out all the useful commands. Useful things, whether you want public or private. I recommend just to always start with stuff in public, because there's this like mentality of like, oh no, I can't possibly code stuff in public because I have to like show that I'm a great coder, and I should just like release it all at once when it looks good. And it's a kind of a hard mentality to get over, but it's very freeing when you do get over that and you're less worried about it. No one is really watching your commit history. It actually looks quite good if you do commit a lot of stuff instead of just like once when it's perfect. It kind of like, if you're ever using your GitHub as like a portfolio, it looks like you're a good developer, you're kind of iterating on your stuff, so it's good. So we'll make it public. There's this license, another really important thing. I'll make this a bit bigger. If you want people to be able to use your code, I highly recommend adding a license. The kind of most popular one is the MIT license. You can look up, there's a whole website explaining all the different licenses for code. It's about how people can reuse your code, whether they have to always attribute you when they do. But if you don't provide a license, then people will be very confused about whether they can use your code at all. And so if you're making something you want people to use, add a license. And it's just a weird legal thing.
So what's the advantage of the MIT license compared to the others? Just the most popular?
It's the most popular. It's not necessarily an advantage. There's ones where people can use it, but they're not allowed to modify your code. People can reuse it and they don't have to attribute it at all. MIT, they can reuse it, they can make modifications, but they always have to give attribution to you, I think. But there's a whole load of options, and by doing that, GitHub will just automatically put in the license spiel, like it copies it from this website that lists kind of all the software licenses. It's quite cool. And this thing, git ignore, I'll tell you, you want to put code into your repo, but not other crap, like not compiled stuff, not data. GitHub's not a great place for putting big data files. So you just want to put code in, and this git ignore system allows you to kind of set up like, oh, ignore files that start .exe, ignore files that start .pyc, which is the Python compiled files. And they give you like a set of like kind of default ones. Let's add the Python one. And I'll show you what that looks like. Here you go. Cool. So I'm creating my repo. I will zoom out a little bit. And this is what they give you initially. I will do two things. You can add a little description up here and topics. Example, GitHub is great. I'm obviously going to delete this one. And a README, really very valuable, add a README. And the READMEs are in this format called Markdown, which is like a really nice way of being able to type up formatted text. So like people looked at HTML and thought this is ugly and annoying and slow if I want to like make things bold and stuff. And so they made Markdown, which you can do things very quickly. So you can add lists. You can add like numbered lists. I won't do all of them. You make like a subheading and a subheading. And GitHub does this nice thing where you can preview your changes. But you can put formatting in, and it's a great idea to put that in your README file. The .md thing means it's a Markdown file, and GitHub will know automatically, oh, I should try and make this pretty. GitHub does that with a bunch of different files. If it thinks it's a table of data, it will try and make it like a nice scrollable and maybe searchable table, as long as it's not too big. It has some quite nice kind of automatic stuff where it will make it easier to look at certain types of files. And so from the web interface, you get this, you can make edits directly to a file, and you can commit the file. And this will, when you commit it, it will go straight to GitHub. Like there's not a version on your computer at the moment. We haven't got to that. It will just go straight to GitHub. And so I will commit this new file, because I've just created this README. And what's nice about it, and you guys might already know this, the README automatically comes up as like the homepage for your repo. So this kind of ugly and pointless, to really put in some actual text of what this does. The other thing that it made automatically, I mentioned the license. One thing up on the right, where my mouse is, it has already figured out, oh, this is an MIT license, and you can go in and click on it, and it gives you this nice little blurb. Oh yeah, liability and warranty, but it gives you nice kind of pros and cons of each license, so you can kind of view that. And here's the actual text of it, like it's copied it, so it's all legalese. And the last one I'll show you from the web interface is git ignore. This is a list of all the files Git should ignore when you're playing around with things. So these are all like anything that finishes like with that strange ending will be ignored. You can often like just search for particular things. Useful, probably the most useful button I find is this edit this file thing. I do this to my README a lot over here, where you click on it and you can start just typing away. I'll do it to my README. And then I can commit the changes. And so this one has updated it. right, cool. So now we have a skeleton GitHub repo. We're going to clone it using the big green button, clone or download. This gives you the URL you want to use. And I'm running this as my lab computer, but Git works the same anywhere more or less. I'm just going to do everything inside a little Hackseq 17 folder. Okay, so it's git clone. And you're pretty much always, yes? Oh, the example file, or? So I made a README file, but I've also made an example project. So the example project, if you go back to your home screen, back to like github.com. I'm probably going very fast, aren't I? Sorry. There's this new repository button down here, right? Cool. So you have something that looks like this. Cool. And so to create that new readme.md file, if there's not one, there'll be this little bar down the bottom along here that says like create a readme. Cool.
Adding some text to a different file?
Oh no, so I did that to the readme file. Yeah, no. So I went into the readme file, and the way I did that was I've clicked on readme file, and now I'm doing the edit this file thing over on the right here. Yeah, I'm sorry, the projector is not exactly the best projector we could have hoped for. And that allows you to edit any file, but mostly you just use it for readmes. You're probably not going to be editing code through the web interface, because you can edit the code, but then you can't test it easily.
Right.
Yeah, no, please interrupt me when I like skip over something or just kind of fly past something. So we have this repo, and this is ours, or it could really be anyone's. If it's public, you can clone it and you can make edits to it, but you won't be able to submit edits to it. If you want to take someone's project and make your own edits to it, what you need to do first is forking it, which I can probably actually fork my own one, but it doesn't really make sense. But you click on this fork button up here, you'll get this little cute animation of GitHub's like octopus thing, which is their logo, with a photocopier, and it will be copying that person's repo and making your own version of it. And then you can start making your own edits to someone else's repo, but it'll be like your copy of their repo. And that can be really useful if someone's been working on some research and it's kind of died, but you like their code and you want to build on it. You fork their repo, start working on it, and then if you think, oh, this is actually really valuable, you can do something called a pull request, which we won't do here. But you can basically submit your ideas back to this person. Like, oh, I improved your code. I think it would be useful for everyone. And that person can be like, either, yeah, that sounds good, or no, hopefully yay. And so forking something, this is like how part of the community of GitHub, this idea of, I'm gonna like make an improvement to someone's software. And like big companies like Microsoft, Facebook, Google, all host a lot of their big projects on here, like their big open source projects, and you can be like, oh, I want this little niggly thing is annoying me, I will make a change to that and submit it to Facebook. And they might be like, yeah, that's good with us. That's the fork button up here. And there's the classic thing of like, you can star other people's repos if you're interested in it and kind of want to see where it goes. And you'll get, it's almost like the Facebook front page, you'll get like updates from their GitHub repo being like, they've made edits to it. Okay, so we have this repo that happens to be our own, and we're going to clone it. So you take the clone or download. The download will just give you a zip of everything, but you won't be able to do anything cool with it. So we're taking this URL here, and there's the button copy to clipboard. So that's what we're going to do, and it has copied, which is nice. And the command we want to do is git clone, and then this thing. And what that's done, I'll use ls, has created a folder with the contents of example project. ls gives the list of things, list of files in directory, and you can see that we've got a copy of license readme. You might be wondering, where's the gitignore file that I know was in there? Gitignore starts with a period, so it means it's a hidden file. So if you want to see a hidden file in Linux, use -a. Just in case you're wondering, like, I made all these files, but they start with a period, and I can't see them in Linux. It's because Linux treats anything that starts with period as a hidden file. In the same way like Windows has hidden files, but it's a kind of different system in Windows. And this will be the same in Macs. Macs will treat period files starting with periods as hidden files. Okay, we're going to make an edit to a file. I will use, there's a text, actually I have nano this. Oh, sorry. I'm going to cd into, change directory into this. Nano installed. Yes. So nano is a really basic text editor. You just do nano in the file name, or if you're really determined, you can use Vim, or Emacs, or there's a bunch of different text editors. It's kind of a pick the one you like. And then you just start typing in this one. And, oh no, I'm saving this. And I'm exiting, which is Control X if you're using nano. And you can save it, and it's saved. I'll show that again. So I added a sentence. And I hit Control X to escape. It goes, do you want to save before you did? I picked Y for yes, and then asks me if I want what the file name I want, so I'm just renaming that. Okay, so I have an updated file. Could be code, could be a README. And the way to check what's going on is this very useful thing, git status, which will show you what has changed. And there it shows that the README file is modified. And now I want to update. So it's modified on my laptop. It's not modified on the website. Not modified at GitHub. I want to push something to GitHub. I have to do a couple steps to do this. I forgot to look this up. I'm going to do an image search because I'm lazy. So there's a thing called the staging area, which is you start making edits and you move things to the staging area. These are the edits that I want to go to GitHub. And then you use add first to make things go to the staging area, and then you use commit, commit to actually store them in a repository. And that's, oddly enough, your local repository. So this is a kind of strange idea for Git. You have a local repository, and then you have one kind of in the ether, which is GitHub. So you can keep on working. You can make lots of changes to your own repo and never push things to GitHub, which would be fine, except if your laptop's stolen, then you don't have any backup. But what's nice is you can kind of keep making changes and save those changes as you're going. And you kind of want everything to go public, or say if you work in a team, you're making a bunch of changes, and you know that the first 5 changes you make are going to break everything for your team members. And it's not until you get to the 6th change that things will work. You don't want to add the first 5 and kind of mess with your team until you've got to it. And you don't want to kind of just not save anything until you get to the 6th, because say each thing is a day long to do. That'd be like 6 days of unsaved work, and it's kind of dangerous. So Git has this thing where you can save at periods along the way, and then only when you're kind of ready, you can push things out. Practically, if you're working on your own, you can just kind of keep pushing things as you go. But it gives you an option of, I'm not going to push until I've implemented this feature, or.
Sorry, so is it backed up when you do a git commit?
So when you do a git commit, it's only on your laptop. So So it's not backed up anywhere but your laptop.
So, when you're talking about like how would you back up intermediate changes and don't want to push to GitHub?
Sure. What you would then do is create a branch. And so you would create that branch and only you would work on that branch. And so you'd be able to push things to that branch to GitHub. And then when you're ready, you can merge that branch back into the main trunk, and what they call. That's a very good, because sometimes you are working for a very long time. You're like, this would be really dangerous to only like keep this on my laptop. So branches. Okay, so the steps for, I'll show you git add. So at the moment we have this file readme that I've changed. I want to tell it that I want to like store those changes in my local repository. So git add and then a file. And if you do git status, now it's in green and it says changes to be committed. It lists the files that are in your staging area. So like green, if you've got colors turned on, green shows the things in your staging area, and red shows the things that won't be added. And then to git commit, we'll take anything in your staging area and move it into your local repository. So git commit, I've updated the README. So this is a really good idea. Technically, you can do git commit and not put a message in. Your worst enemy is you from 6 months ago. Put messages in so that you can like go back and be like, oh, I know I put that code in there somewhere. Or like, this thing broke and I have no idea what this commit was even supposed to do at this point. Was this important? Can I try and go back and change things? So that little -m gives an update. Cool. Importantly, so we've committed things. Website, still no change. Let's go to this thing. There's not those extra sentences here. And the command that you will need is git push. And it will ask for your GitHub. This is the stage where things actually go to GitHub. You have to put in your username. Get this kind of funky thing. And it's updated. I refresh this, bingo, there's my new sentences are now on the website. So it's like git add, git commit, git status if you want, git push. Add, commit, push. Next up, you're working with someone else. And they've committed some changes. We'll just do it on the web interface, but imagine this is one of your collaborators. They've added in the extra sentences, README or code or whatever. And the command to get their changes is git pull. If you push things to GitHub, you pull things back from GitHub. So I'll just show it before I do this. I'll use nano. So I made those edits on the web interface. They're not on my laptop because I haven't done any kind of update, as you might expect. But if I do git pull, it tells you what files have changed. So one file changed, readme ++, that's the number of lines. And you'll see there's like this weird gobbledygook updating 09E95, like just lots of letters. So in some repositories, it has this kind of numbering system where it'll be like that's when you start a project, the first thing is commit 1, then commit 2, then commit 3, then commit 4. But because with GitHub, multiple people can be working, and like there's no obvious like how do you number these things. if one person's making edits on a local repo and another person's making edits on their local repository, and you like try and track the times, these things aren't communicating with each other, so they don't use a numbering system. They use this hashing system. So those little letters and numbers is a hash, and it can be quite cool because you can use that to refer to a particular version of your software. So say you were making updates to a thing, or one of your collaborators made updates to it, you can go back to previous versions and find when it, they broke something, damn collaborators. And you can find the version that worked, and you can refer them to it and be like, oh, it works at hash 09 whatever, and they can easily get to that, and then you can step through and figure out what the problem was. So it's not a numbering system, it's this kind of weird letters system, but it's fine. And the web interface has some nice stuff where you can, if you click on, well, I'll go back to this. You can look at commits and see each one of these has the weird numbers and letters. This is like the first 7 characters of the hash. The hash is actually much longer, but it's just, and you can click on one of these and it'll copy it to your clipboard, and you can use it for some other commands. You can, if you have multiple files in there, you can do some tricky things where you have one file at a different version. Then one file used to work, and you're checking whether the other files that are up to date work, and you can kind of move things through time and different things. Yeah. Oh yes. So let me make a new file, and I'll show you. So remember, I've made a change to the README file on the web interface. And I haven't pulled, I haven't got it yet. And we'll try something. This is Python, just adding a little X. So I just create a file that just says print hello world. I do get status, it looks new. I'm going to do the git add, git commit. Remember with the -m little message. And now I want to push it to the repo. I want to add this new file. I put in my username, password. Cool. Now, let's say I want to pull the latest thing from the repository. I need to change that file. Oh yes, and now through that, I must have run git pull, sorry. Oh yeah, I ran git pull because I'm forgetful. History is a useful command if you don't already know it. It shows you all the commands that you previously run. Cool. Yes, I ran git pull up there. I'm being forgetful now. Okay, anything else? Sometimes if people have made lots of edits to your repository, it will come up with an error message that just says the remote repository is more up to date than your one. And so you'll before you can commit things to, before you can push things, you will have to pull things first. Basically, if the push fails, try pull first. That's the kind of secret things. It will, depending on what files have changed, it will automatically detect, if you were working on a file and they were also, your collaborator is also working on a file, it will try and resolve So like try and merge paragraphs intelligently. Sometimes it fails, but that's something we won't go into now because it's already been quite long. But yeah, it will try and do kind of a clever merge. It's called merge conflict resolution. I think that was more or less everything I was going to go over. Simple. So git add, git commit, push and pull, and git status for showing things. Oh, I will, sorry, one more. I'll just show you a couple of useful things. Okay, so I've just made a small change to this file. I'm saving it. And the other useful command is git diff. So first of all, I'll show you git status. It's telling me that I've got one file changed. And git diff, if you run it on its own, it will show you all the changes. So you might have made really dramatic changes, and that would be a bad idea because it'll be like hundreds of lines. But here, we only have one thing, and so it will show you this. And this is super useful for like, oh, there's a bunch of code that's changed in my repo. What have I done again? Like you know you want to commit something, but you can't quite remember all the things that you've done. So git diff will tell you all the changes, and then you can. It's useful like just before you're about to write that useful commit message to actually check what you're about to commit. You have to do git diff before you do git add. Git add first, it won't show you differences. Git diff only shows you stuff that you haven't added yet. And there's a way around it, but it's kind of annoying. And you can do git diff on a specific file, which also might be useful. And oh, you can also do git log on a file as well, which gives you a kind of a long log of all the changes you've ever made. Oh, and you can, I'm just thinking around the things. You can also just do git log, which will give you your entire history. And see again, this font is a little bit ugly, but our color. It says commit. And then there's that hash, and that's like how you would refer to particular versions of it. It's not a number, it's a long string, but that can be very useful.
So if you're not working with it, these commands work with
yes, so what you can do is, there is software called git bash, which you can install on Windows, or I actually have both, or you can use a thing called tortoise, SVN, git. Tortoise git, which is like a GUI version of this. And so I have, you can just do all the like right clicking. It's the same concept. Like it will tell you, there's a commit button, a pull button, a push button. And that can be quite nice because it can do quite like, if you want to do a diff, it can show it in quite a nice visual way what differences between files. But yes. So this is tortoise git. So Mac, you can run, I don't know for like a nice visual one, but I mean Git is installed on that, I'm pretty sure. Yeah. I imagine it's probably there, or you might need to install developer tools. Yeah. If you install, a good recommendation for just like general installing stuff, Anaconda, she's like this kind of Python distribution, brings a lot of useful stuff with it. And if you want to learn Python, yes, yeah, Conda, it's like a kind of neat package management thing for Python. I will say, so this was a kind of a very shortened version of the software carpentry workshop, which goes into more stuff. There we go. So they have like, has a lot more of a kind of follow along thing. I highly recommend. So it's software-carpentry.org/lessons. You've got stuff on the shell, the terminal, Git, Mercurial, which is like an alternative to Git. You can probably ignore it because Git's cooler. Python they're all like kind of one-day workshops or maybe half-day workshops. I think the Git one is about full 3 hours, but I've taught you the kind of the main things of add, commit, push and pull, and diff, and status. I feel like those were the important ones. But yeah, I highly encourage you to have, are all you guys researchers? Or, yeah, put your research on GitHub, especially like that's where your code should go. And there's other great resources for like where your data should go. Zenodo, Z-E-N-O-D-O is a great one. I'll post all this stuff on the general Slack channel. If you guys have any other questions. I'm not going to pretend to be a complete Git expert though. Yes?
I've got my branch.
Yep.
So I'm looking behind the master.
Yep.
So I could do Git origin, and that will everyone that.
From a branch, I think Git pull origin would probably just pull the latest version of the branch, not the latest version. This is what actually we're I should say. Okay, any virtual participants listening, I think we're going to stop sharing screen now. Any questions, please post to Slack. Cheerio.